Hello everyone. In this video we're going to be dealing with a radical equation. We have the fourth root of 17 minus x squared, and that equals 3 minus the square root of x. And we're going to be solving for x values, real and complex. So if you look at this problem, since we have the fourth root, it kind of makes sense if we raise both sides to the fourth power, doesn't it? So we can go ahead and do that, definitely. Raise it to the fourth power. The radical on the left disappears, and on the right hand side we kind of get like 3 minus root x squared. So you may want to just square it first to see what that looks like. It is going to be 9 plus x minus 6 root x, and then we're going to have to square that again. And actually you could also do this instead of raising both sides to the fourth power. You could do square, but you know, it's the same thing pretty much. So we get this equality. And if you square this term, you're going to have x, you're going to have square root of x, and you're going to have x times square root of x, which is going to produce more radicals. At some point, you may be able to get rid of all the radicals. I'm not sure if it's possible at all. But as you can see, this is going to be messier and messier as you square both sides. So we're thinking there must be an easier way. And since this problem could possibly appear on a math contest, because that's pretty much what this channel is sort of about, because a lot of the problems are level of, you know, competition level or Olympiad level problems, even though some are very easy. Anyways, so we're going to use a different approach. So let's go ahead and leave it at that and rewrite the problem. We have the fourth root of 17 minus x squared equals 3 minus the square root of x. So instead of squaring or fourth rooting or fourth powering both sides, we're going to use a very powerful method, a very powerful tool that I've been using almost all the time, and you must be familiar with that. I'm pretty sure you already know what it is, and it's called substitution. All right, so here's what we're going to do. We're going to call this whole thing B and call this A. And of course, the whole thing is B, meaning that this is also equal to B. So from here, we get some equations. Let's go ahead and write them down. We're going to get rid of all the radicals, but in a nicer way. First of all, A is equal to square root of x. Now, what happens if you square both sides? You get A squared equals x. Okay, great. Let's do it. A squared is equal to x. Fine. Let's take a look at this now. 3 minus square root of x is equal to B. B is equal to 3 minus the square root of x. Now, here's one thing that's going to be very helpful. If you take these two things together, what happens if you add these two equations? Square root of x cancels out. You end up with a plus b equals 3. And isn't that nice? You got a linear equation, no radicals, none of that nonsense. But this is not enough. We need to do more. And notice that we call this guy b. So what did I call b? I called the fourth root of 17 minus x squared b. So b is equal to that. So I can raise both sides to the fourth power to get rid of the radical. So b to the fourth power becomes 17 minus x squared. Awesome. Now how can I use this? Is there another fourth power? I don't have a fourth power, but I do have a second power that I can use. So I can go ahead and square both sides of this equation, and that's going to give me a to the fourth power equals x squared. And notice how beautifully everything cancels out, and we get a nice system of equations. I hope this makes sense. So we're going to add these up. X squared cancels out. We get a to the fourth power plus b to the fourth power is equal to 17. And I'm pretty sure at this point you already guessed the solution correctly, right? Okay, that doesn't matter much. I mean, you can guess and check, definitely, that's totally fine. But let's go ahead and systematically solve the system, because solving the system is also going to teach you some algebra tricks which will be very helpful in the long run. That's why I don't just want to rely on guess and check, but I also want to show you the solution method. So here's what I'm going to do first. I'm going to start with the a plus b, and I will square that. Let's go ahead and square both sides here. That's going to give us a squared plus b squared, my favorite way of expanding this, plus 2ab equals 9. I don't know a squared plus b squared, so this doesn't really seem to help, but I do have the sum of fourth powers, so why not isolate the sum of squares and then square both sides one more time. That's why being able to use these identities is crucial in solving math Olympiad and math competition level problems. Now when you expand it again with my favorite method, a to the fourth b to the fourth plus 2a squared b squared equals, how do you square a difference? A squared plus b squared, again my favorite method, minus 2ab, but 2ab meaning like 2mn, 2xy, whatever you want to call it. Multiply these two terms together and double the product. That's going to give us 36ab. Awesome. This looks very messy, doesn't it? It does, but don't worry about it because we do know the value of a to the fourth plus b to the fourth. So we can go ahead and plug it in, and guess what? Everything else is a function of ab. So we can use substitution one more time. Yay! Substitution is awesome, don't you think? So this is 17, and then plus 2ab, a squared, b squared. So I'm going to go ahead and maybe, I don't know, should I just bring it over here? Most probably I'm going to use the other side. So let's leave it at this for right now. Let me go ahead and subtract this from 4a squared, b squared. So I'm going to leave the 17 alone for now and do the following. 81 plus 4a squared b squared minus 2a squared b squared is going to give me positive 2a squared b squared, subtracting like terms. And then I have the minus 36ab. Okay, remember that came from 2xy. Great. What can I do with this? Put everything on the right hand side. 2a squared b squared minus 36ab plus 81 minus 17, which is 64, is equal to 0. Divide everything by 2 and use substitution. Substitution is very powerful because you could continue to use it. You could always use it. Okay, great. I couldn't say it. So suppose AB is equal to something. How about AB is equal to P for product? So we get P squared minus 18P plus 32 is equal to 0. This is a quadratic equation in P. Don't get me wrong. And this is factorable. So we can write it as, so we're thinking about the following. Find two numbers whose product is 32 and whose sum is negative 18. Those numbers are negative 16 and negative 2. Therefore, my factors are going to be P minus 16 and P minus 2. Therefore, P is either 16 or 2. But what is P? P is AB. So if P is 16, AB is 16. But we knew that A plus B is 3, right? So A plus B is 3. So that gives me a system. AB equals 2 and A plus B equals 3. Gives me another system. I have two systems. I'm going to solve this. And I'll show you a graph at the end, like I said earlier. Did I say that earlier? I don't remember. Anyways, let's go and solve this first because that's easier. Think about two numbers whose product is 2 and whose sum is 3. Those numbers are 2, 1, and 1, 2. Yay, those are AB ordered pairs. This one, not that easy. You could do the following if you want. Subtract A from both sides. Or make up an equation using T, another variable, using Vieta's formulas. And Vieta said the sum of the roots goes here with a minus sign in the quadratic, and the product goes here as a constant with a plus sign. So that's my equation. Let's solve it using the quadratic formula. The T values are going to give me A and B. T represents A and B at the same time. Makes sense? So from here, T becomes negative B plus minus the square root of B squared, 9 minus 4 times 16. You're like, what? Okay, T is not real. So T becomes 3 plus minus negative root 55. So I can write it as root 55i divided by 2. But what is T? T represents A or B, right? So this is A or B. Since they're interchangeable, let's just focus on A for now. Notice that our equation is symmetrical. Anyways, so what is A though? A is, do you remember? A is square root of x. Yay. Uh-oh, that didn't go well. Okay, I was trying to do this. So A is equal to square root of x, which is nice. Let's go and replace A with square root of x. So what do you need to do to find x? Square both sides and you'll get the x values. It's that easy, right? 3 plus minus square root of 55i divided by 2. If you square this, you're going to get, after simplifications, negative 23 plus minus 3 root 55i divided by 2. So that's going to be another pair of x values. We also have the 2, 1, and 1, 2 as our ordered pair. But what is x in this case, right? We didn't talk about x. Okay, if a, this is a, this is a, by the way, the first numbers in the ordered pair. If a is 2, x is 4. If a is 1, x is 1, because you square the numbers. Remember those values? We're going to look at the graph now, and hopefully you're going to see them, except for the complex non-real values. So x equals 1, x equals 2, 4 are the solutions. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.